A woolly mammoth tusk was found with 0.1% of carbon-14 remaining. About how old is the tusk? Here's the half-life formula. A is the current amount of whatever isotope you're analyzing. P is the principal amount or original amount. And then you have, and T is the time, and H is the half-life. Carbon-14 has a half-life of 5,730 years. So we're going to use that in the calculation. And this 0.1%, that's the ratio of A to P, the amount you have to the principal amount. So A divided by P equals 0.1%, or I'm going to say 0.001, because that's 0.1%. Okay, so now what we need to do is just use this formula here to solve for the time, and that'll tell us how old the tusk is. So I'm going to take this formula and divide both sides by P. A divided by P equals 1/2 to the T divided by H power. Okay, now I'm going to substitute in what we know. A divided by P is 0.001 equals 1/2 to the T divided by 5,730. Okay, so now I'm going to do a little bit of algebra. I'm going to take the log base 1/2 of both sides, and I'm going to get log base 1/2 of 0.001 equals log base 1/2 of 1/2 to the T divided by 5,730. Now this right side simplifies a little bit. Log base 1/2 of 1/2 to the T divided by 5,730. That's all very complicated, but using rules of logarithms, that just simplifies to T divided by 5,730. So you get log base 1/2 of 0.001 equals T divided by 5,730. So I'm going to continue over here. Multiply both sides by 5,730, and I'm going to get 5,730 log base 1/2 of 0.001 equals T. So some calculators can do log base 1/2 of 0.001, some cannot. So my calculator can't, so I'm going to use the change of base formula. I'm going to rewrite this in an equivalent way, or you can enter it in any calculator. So 5,730 times log of 0.001 divided by log of 1/2 equals T. That's called the change of base formula. I'm rewriting this logarithm, and this is an equivalent form that can be entered in the calculator easily. So let's go ahead and do that. 5,730 times log of 0.001 divided by log of 1/2, or I'm just going to put 0.5, that's the same thing. You could put 1/2 if you wanted to. 57,103 years. So I'm just going to round that to 57,000. Okay, so let's review the process. Started off with a half-life formula, and then we rewrote it so that we could use the ratio of 0.001 or 0.1% easily. And then we substituted in what we knew, solved for T, and we used the change of base formula so it'd be easy to enter in the calculator, and then solved it from there. So there is a good bit of algebra in here, and you do need to know your properties of logarithms in order to do this algebra.